and let's talk in the next little bit about how to get your DAGs to work correctly before going into production, and make sure they don't break into production, so you don't have to go hacking around over there. So a little bit about myself. I have a background in software engineering and computer science here in the Netherlands, and I've been working as a data engineer at GoData Driven for the last 4.5 years. So below you see two pictures of what I like to do in my personal time. Ideally, I like to travel a lot and take the car and drive to very far remote locations. And in my professional time, I'm a data engineer, so anything that has to do with a lot of data and making cool software that excites me. In that process, I work a lot with Airflow, and as a result of contributing a lot and being active in the community, I'm a committer on the Apache Airflow project. And at some point in time, I and a colleague decided to write a book about Airflow. We didn't see a book yet. We thought it was the perfect time to write the book. So we're very close to the end of writing the book Data Pipelines with Apache Airflow. As you can see from the picture, it says MEEP, which is the Manning Early Access Program, which means the first 10 chapters are available online in a preview. So it's like a word of warning that some things might still change. But we're very close to the end and to releasing the last 5 chapters. And then it will take a little bit for the book to be printed and to actually be able to hold it in your hands. But the end is near. So soon this won't be in MEEP, but you will actually be able to buy the physical book. But if you want to read it right now, it's already available on the link that you see over there. So title of this talk, ensuring your DAGs work before going into production. In the next half hour, 45 minutes, I am going to talk about a couple of topics related to testing. It's maybe not the most exciting topic to talk about, but I think what does bring a lot of it's like solving a big puzzle when you write a DAG, you test all the bits and pieces, and it goes into production and it's green on the first go. That gives a nice sense of achievement. So I'll go over a couple of topics tonight, and specifically these topics in relation with Airflow, to see where you can and where and how you can test Airflow components and your DAGs. So whenever I see people starting with Airflow, typically they start it up, they start developing their workflows, their DAGs, and their very first deployment and workflow looks somewhat like this. So you have a developer here. They have their workstation, so a laptop or a virtual desktop or whatever it is. They have some IDE here, like PyCharm or Visual Studio or whatever tool they use. With this thing, they produce a bit of code. They push this to Git or some version control system, and this somehow ends up in their Airflow installation, either via a volume or they push it or whatever happens. It ends up in Airflow, and this is the one and only Airflow they have running in their company or their system. So Airflow picks up their DAG, and then they click trigger DAG, they let it run, see what happens. If it's green, great. If it's red, they go look in the logs, they check out the errors, they go fix and redo this process. So they have one Airflow for production and testing and development and everything else. For various reasons, this is obviously not ideal. So when a project starts growing and growing, their setup starts growing a little bit as well. So this might be a second attempt at getting somewhat of a more nice solution in place. So same setup, you have a developer, their workstation, version control, But now, instead of one master branch, they have two branches, a development branch, where they develop on their own branches. They push to a development branch, test out their changes in a development Airflow setup. So this still involves clicking on trigger DAG every now and then. Sometimes they see a red thing, they go in the logs, fix the code or fix whatever error there is until they click trigger DAG and all the runs are green again. Once that happens, they merge to master, and then this is the production setup where you don't have this sort of junk of filter runs and attempts to get stuff correct. And the production setup is sort of a clean version of your workflow. So still not ideal. One of the main reasons that this feedback or development cycle is very long. You write code, you commit, you wait for a deployment to happen, you click trigger DAG, you wait for the whole thing to run. It's just a lot of steps, a lot of waiting, a lot of time, and it's not ideal. So let me start with sort of a statement. Testing Airflow is hard, or maybe I should say not trivial. I hope at the end of the talk it's less hard. And why is that? So you have data processing frameworks like, let's say, Pandas or Spark, where you have certain transformations on data, and there you can keep your transformations together with your code and your tests and everything together. But the nature of Airflow is an orchestration system, and it's not one single piece of code that you're typically testing, but it's typically you're running workflows or tasks that lie outside the reach of Airflow. You're just starting a task there. For example, it could be a query on a Postgres database, or it could be write a file to Amazon S3, or start a Spark job on a Spark cluster that runs on some other remote location. And all that Airflow is doing is basically starting the job, checking if the thing is running, and then once it's completed, then Airflow goes and does something else. And what people typically want to test if their entire chain of events or workflow works as intended. So that's why I think that Airflow testing is kind of hard, because you have to ensure that the whole chain of events or this whole integration of tasks works as you'd like it to work. And for example, your production system, that could hook up to a Postgres database and Amazon S3 and maybe some other systems. So in order to ensure that your workflow also works in development and locally, you would also have to connect to these systems from all the other machines that you're developing or working on. And for obvious reasons, this is not ideal from a security perspective. And that's why this is one of the solutions, that you set up the same environment with all the tools and components for every environment that you're working in. But this is also a lot of work. So in the next few moments, I would like to show you how to develop on your workstation, on your laptop, locally, without having to create a full duplicate or full dev test acceptance production environment. And you can develop faster and also ensure that your code works correctly once you go to production and connect to these real live production systems. So let's start with unit testing. And before going into the details, let's start with defining what is a unit test. Definitions vary, but I think unit testing is basically testing individual pieces or components, so individual pieces, logical pieces, and you can have many unit tests. And if you unit test all your individual components in your system, it should at least give some guarantees that your code is going to work correctly. Maybe if you run a chain of events, or a set of tasks that all work together. Maybe if task A produces some weird value which is still successful, but task B then picks up this weird value and doesn't know what to do with it, then fails, then you would have to test multiple components together, which is obviously called an integration test. But for now, let's look at a unit test. So let's say you have a function called countLines in Postgres table. Given a table name, it does a select count. So your test could be run the function, give it a table name foobar. Let's say we have a development Postgres database, and we know in this table foobar there are 5 rows. So we would assert that the result indeed equals 5. And that way we can assert that given a table name foobar to this function, receiving a value of 5, we know that basically the behavior of this function is correct. And this unit test is ideally what you would run on your workstation or maybe in your CI/CD system, in your version control. And a unit test is, I think the goal of a unit test should be, you should be able to run it fast. It shouldn't be a whole, or at least one unit test should be able to run fast. Maybe you have thousands of unit tests that together become a bit sluggish, but one at least should be a simple thing to test. Either in your workstation or your version control, and then you can have some sort of gut feeling that that the whole thing together will work in production. So unit testing and Airflow together, and this is kind of why I say Airflow testing is hard. Because Airflow is an orchestration system, and the idea of Airflow is that you orchestrate or manage multiple tasks in a certain order. So workflow consists of operators, and I would typically test an operator just by itself by running one individual operator, and I would do this. Maybe I would do this for every single operator in my DAG. And if I give it some correct data and it succeeds, and if I give it some incorrect data and then it fails as I expect it to, then I know at least every task by itself works correctly, and it gives me some gut feeling that the whole thing together also works. So you would unit test maybe individual operators, or even if the operator is calling some functions under the hood, you could test the individual functions that it's calling. And that way get some guarantees that your stuff is working. So like I said, a unit test does not validate basically these dependencies. If start2 produces some weird value, maybe the task start2 would succeed, but task 1 would then fail because it gets a value that it does not understand, for example. So how do you unit test an operator? So let's go to the code. And typical consultancy answer is always, it depends. And let me show you why it depends. So here's a test for the Python operator. And it's basically, you define a Python operator. The task ID is a required argument. So you can give this whatever value, and typically name it test or task or whatever. And in this case, I have a Python callable that returns the value test me. So this thing is returned. We define a Python operator here. Once we run execute, then test me is a value that is returned. Execute takes a context. So if you just run in the Airflow system itself, this context is filled automatically, but for the test, we have to, for now, set it to an empty context. Result is then, test me is then captured as this result, and we can assert, does result really equals test me? If so, yes, okay, then we can have some, we know that the Python operator works in this case. So let's go to the bash operator instead. Basically same thing. Task ID test, instead of a Python callable, we give it a bash command, like echo test me. there's no return keyword in Bash, or at least not to return a value. It does return an exit code, but that's not, so it doesn't give the same behavior. And the reason I say it depends how you unit test operators is, here's one example. The XCOM push equals true. The bash operator does not return values by itself, but when you give it XCOM push equals true, it would actually get the value from the standard out, which is in this case will hold test me, and then return that as a value. So with this thing, we can capture basically the outcome, which is test me, assert it, and again ensure that the bash operator works. And here's sort of the proof why it depends. This is the base operator, and the base operator holds a method execute, which every operator should implement for itself. And we've already seen in the bash operator and the Python operator, the way it returns values differs. So sometimes when you're testing, you have to dive into the implementation of the operator to see how you're going to test it. If you write your own operators, then you typically know how it works. But if you want to know how if you want to test an already built-in airflow operator, then sometimes you have to dive into the implementation. And note the context equals empty dict. It's a required argument here, so that's why you always have to at least give an empty dict to run a unit test. Let's make it a little bit more complex. Let's say you want to test and use some context in there. So using the execution date from the context in your task is a very common task. And let's say we want to test with that thing. So once again, we're going to test a Python operator. And the Python callable, in this case, will call next week, which is this function. And the function takes the context, it pulls out the execution date from the context, and then adds 7 days, or also known as 1 week, and returns that value. So we can assert, does the result really equals the date in 7 days? So this example is still very simple. So instead of giving a empty context dictionary, we can now set execution date by hand, basically. So within Airflow, when you run a task, you get this list of like 20, 30 context variables that you have available to use within your task, like the execution date, DS no dash. But just running an operator and calling .execute will not have a context unless you give it yourself. So this way we can give it a fixed execution date and work with that. So before going into more complex examples, I want to show a little bit about Pytest. If you're not familiar with it, the default library in Python is unit test. That just comes built in with Python. But I see a lot of Python projects and a lot of people preferring Pytest for various reasons. I think it has some nice features, which I'll show in the next slides, and which make testing a lot more, a lot easier. So to install it, run pip install Pytest. And here's an example of what a Pytest could look like. So on the right, we have unit test. We have a class, and a typical unit test class holds a setup and teardown, where the setup instantiates a couple of variables. You can use this throughout the test in your test class, and a teardown method, which I haven't shown here, would destroy anything. Maybe you have some initialized database connection that consumes some resources, so you want to destroy that thing. In Pytest, you have these things called fixtures, and they work they provide some similar behavior as this setup thing, but they provide a bit more flexibility, which I think is one of the main features of Pytest. And here they're defined as a function and annotated with @pytest.fixture. And you can use the value that this thing gives us by providing it as an argument in your test. So you can have, for example, def c return free, give it a annotation Pytest fixture, and then add it as an argument here in test sum, and then you have the value free to your availability. And the big difference with unit test is, I think, whereas with unit test you set up a test case just once, and then you have multiple tests with that setup, these fixtures allow for more flexibility because you can sort of mix and match these fixtures throughout your test functions or methods. This is basically what I explained. Let's say you have a third variable, self.c equals 3. Then in unit test you would just add it to the setup and then use it in another test. The thing here is that in test sum AC, the value of b is also accessible. So if b would be a mutable value, basically, then one test you could mutate it, and in another test you could actually sort of what's the word? You can actually create a different result for your test, which is obviously not what you like. So with these fixtures, they basically instantiate by default for every function, and this only scopes to the fixtures A and C. So these Python fixtures are, they can have a certain scope, and I think this is one of the strong points of Pytest fixtures. By default, they have the function scope. So if we go back to the previous slide, meaning every fixture here will instantiate only once per function. So if you have a new test function, it would instantiate the thing over and over again. But you can instantiate these fixtures differently depending on the scope you like to instantiate them. So for example, expensive operations like database connections, you would instantiate with, for example, the scope module. So here I have an example of what not to do with a Python fixture. So here you instantiate a fixture with scope module, meaning this value is instantiated only once for the entire module. Here we edit the variable, and then if we reuse it over here, then it holds a different value than as it's instantiated with, which is obviously not what you want. If you append 1 here, then this list will be 2 ones, and this sum will give a different result, so result in a failure. So be careful with these scopes. I think they can be quite powerful for example, using database connections, expensive things to instantiate, but they can also be a bit tricky to work with. So I already mentioned this. Module scope, especially useful for expensive things like database clients, or things where you want to keep state, for example. But ideally, a test is an individual thing which just works by itself and does not depend on other tests. So just before going back to Airflow itself, there are a couple of built-in fixtures. So I show you a couple of basically self-made fixtures, but there are also built-in fixtures. I'll give you an example of the temp dir. But if you want to read up on all the other fixtures, I suggest you go to the documentation. The Pytest documentation is fairly structured, and it's actually, if you start testing, it's actually very useful to read through the documentation to know what sort of exists. So the temp dir is a Pytest fixture. Again, you provide it as an argument to this function, to this test function. And the temp dir is basically a temporary directory which exists for the duration of your test. It's a magic directory basically on your own file system with a bunch of characters in the name, and it's deleted afterwards. So you can use this throughout your test. So let's say you have a bash operator with a bash command that says echo hello, and write this to the temp file that we created here. Then we can assert, did I really write one single file, and not two, not zero, but exactly once? And does it really contain the string hello like we wrote here? So this is how we can use a temporary location on our local machine. So enough Pytest, show me Airflow. So whenever I start a project and I start to create a test directory, this is typically what I start with. I think this is one very useful plugin with Pytest. It's the Pytest helpers namespace plugin. And you can kind of see it as a way to create global-ish functions throughout your tests. So you have to install this package, and I will show you where to put all this code in the next slide. But you have to state Pytest plugins equals helpers namespace, and that gives you this thing, Pytest helpers register, this annotation, and this function will then be available throughout all your tests. And what this does is it takes one task and one DAG, and it runs the task. So we defined a DAG fixture here, and I'll show you some examples of why we need this DAG. And then we can use this run task thing to run it, so you don't have to redefine how to run or how to execute a task every single time in your test. So this is basically the very minimal project structure that I typically have. On the root level of my project, I have a DAGs directory with my DAGs. I have a source directory and with some custom components in there, custom operators, custom hooks, and a test directory where I have one file named conftest.py. And this thing, what I show you here, is what I put in my conftest.py. And conftest.py is basically a magic file that Pytest will read every time, and basically is available to all your tests. So how do we actually use this thing? Just like before, we have the bash operator, and we call .execute on the bash operator. Execute is basically what Airflow calls under the hood when it runs a task. And that whatever logic is defined in there will then be executed. But there's a couple of layers of abstraction in Airflow, and this thing, task.run, is basically one level above, and in there the context is actually given or generated and then given as an argument to your task. So in order to work with the runtime context or the task instance context in an operator, you would have to call this task.run function. So that's why I have this helper function that I can use to run a task and then assert if it really worked. So here's an example. I have the Python operator. I provide context equals true. This ensures that the context is generated for this Python operator and given as keyword arguments over here to this variable called context. So in this test, I open a file to a magic location defined by tempdir. I write context ds, so that would be the string year, month, day. I write it, I run the task, and then at the end of my test, I open this file and assure that whatever is contained inside this file indeed is the the starting date of my task. And also, when I start a project, then the very first test that I actually add to the project is called the DAG integrity test. I sort of copy paste this throughout all the projects, and it validates the integrity of all my DAGs. So basically, can Python instantiate a DAG object? And it's kind of inspired by this blog post by some guys from ING. The blog post is titled 7 Circles of Data Testing Hell. So if after this talk you're still interested in testing, I strongly suggest to read this blog post that I think is very useful. And I will show you layer 1, the DAG integrity test, but this covers a bunch more about testing and Airflow. So the DAG integrity test it's kind of like the hello world of checking if your DAG is a valid DAG. What basically, bluntly said, what Airflow does under the hood is basically calling Python your DAG, and it just runs through your code, tries to initialize all the objects. If you give, for example, the DAG class a legal argument, then it will say, I don't know what this thing is. So this check ensures that at least those basic things are correct in your DAG. It doesn't, the DAG integrity test does not check if your DAG takes long to load, but at least if you yourself run Python your DAG and it takes a long time, it is a strong indication that something iffy is up and you should go fix. And this, the last line, anything in the global scope must be avoided, I think is a very important pointer. For example, if you put a time.sleep, say in the global scope of your DAG, then that should indicate, something is wrong. But for now, this is the DAG integrity test. It might look like a bit magic code, especially at the end in this import file thing. But the key point here is basically we have this DAG paths, which globs or selects all Python files in this DAG directory. So we assume that every Python file in here holds a DAG. We create a parameterized test. So for every DAG file, it runs this test. And what the test will do, it will import the file and assure that the DAG can be instantiated. So if it doesn't contain any illegal keywords or whatever. And next, it will test if there's a cycle in here. So before, I believe it was version 1.10.2, this test cycle was actually inside the DAG in it. And it would you wouldn't have to add this to your DAG integrity test, but it's a very expensive operation, especially for larger DAGs. So that's why it was removed from the DAG init, and that's why it's here as a separate statement in the DAG integrity test. So if you have, say, 2 tasks and you do task 1, task 2, back to task 1, you run this test, then this is what happens. You get a Airflow DAG cycle exception, cycle detected, and this should be able to run on your laptop or in your CI/CD system instead of figuring out that you have a cycle in your production system. So let's talk a little bit about mocking, and I see I have like 10 minutes left, so I will speed up a little bit. So mocking is basically the art of providing canned responses or fake responses to basically code that will make calls to external systems. And the idea behind it is on your laptop where you're developing, you don't always have access to your production system. So you can't always call your production system. But instead, you would sort of plug in into your code, say, at this point, I'm going to make a call to my production system, but instead, I'm just going to return something that the production system should return. Word of warning, mocking sometimes requires digging into internal code. It's a bit more complex. So let's show an example. Let's consider an external API, and by external I mean something that lies outside our reach and is not maintained by ourselves. So there's this API called Sunrise Sunset. It's a free API you can use for testing whatever, and it returns us some information about sunrise and sunset times. And this is JSON thing. So let's say we write a DAG for it, and in this DAG we call the simple HTTP operator to check at the time of calling this thing if it's light or if it's dark, given the response of this sunrise sunset API. Now what the simple HTTP operator will do is you have to feed it a HTTP connection ID, this thing, and Airflow will then go to the meta store, pull out the connection, and then continue its work. But in your CI/CD system or locally, you do not have access to the Airflow meta store unless you set one up, obviously. But it's much easier, or it's much more predictable to mock out the connection, the get connection call to this meta store. So basically, we're saying on the base hook, this is where the get connection call, which goes to the meta store, pulls out the connection and returns it. We're just going to return this object with this host name. And this avoids basically communication with this with an external system, which in this case is the meta store. The test will actually call the API, but if you cannot reach the API from your laptop, you could also mock out, for example, this response and provide this response as a dummy or test. So that's mocking. So I showed you Pytest and mocking. Important thing about it to say is unit test comes built in with a mocking package. And this is basically usable throughout your code. But I think in Pytest it's a bit more convenient to use this plugin called Pytest mock. It's kind of like a little wrapper that allows you to use the mocking library from built-in mocking library from Python as a fixture. So let's say you're writing tests, you're mocking some stuff out, but sometimes this is not always possible. Let's call it the unmockable. So how do we mock the unmockable? You have a couple of options there, and I will show you the first two of this list. So how you can mock and assert calls made to external systems, but also how to run a Dockerized version. So once again, we have the simple HTTP operator, which calls my function. And instead of making the actual call to this API, let's assume this is now not accessible from my laptop, we mock, or we patch, I should say, this method called run on the HTTP hook. So this is why I said you have to dive into the code sometimes, into the implementation details. We have to know that this thing exists so we can patch it out. And basically what this statement does, mocker.patch object, is it will basically replace any calls made to this thing and capture it in this mock run thing. So we define our operator, run our task, and now we can make assertions on this mock run object. So we can assert or test what has happened and what we expected the simple HTTP operator to do. So we can assert, is it really called once? And is it really called with these arguments? And in this case, the actual test is testing if DS, defined over here, was indeed replaced with the value of what was defined here. So sometimes, you can go up to mocking a lot of stuff, but sometimes it's just more convenient to work with a real system. I think this is where the power of Docker comes in. So what you could do, there's different ways to do this. You could create a Docker compose file which you use throughout your test, which brings up a couple of Dockerized systems. Yet another plugin for Pytest that I particularly like is this Pytest Docker Tools plugin. So I'll show you a couple of examples of how that works. It's basically a small wrapper around your Docker client, and it provides you a set of Python fixtures with which you can use Docker within your test. So say we implemented a Postgres to local operator. So you run a query on a Postgres database and you write the result to your local file system. So we have a couple of components. We have Postgres and we have our local file system, and we somehow need to test if this thing works. So what do? We import from Pytest Docker Tools container fetch, and this kind of maps to your Docker CLI by just in Python code. So we fetch the image. We define a couple of settings for a container. So this kind of maps to, the arguments kind of map to what you're used to in a container, so environment, ports, volumes. So magic trick about the Postgres container is that you can supply a SQL file in this path, this initDB path, and it will actually run whatever statement is in the SQL file at the start of the container. So you can create a database, create tables, create data that you can test with. For example, you insert some dummy values into a table called dummy, and then, especially with mocking, your tests start becoming longer and longer in terms of lines of code. So again, we have to mock out the Postgres connection. So we give it a connection to localhost with a couple of settings. Here we have our operator, Postgres to local operator, where we just run the Slack query. And the output path is this tempdir fixture, which I also showed you using the Pytest fixture. And then we can assert if it's really what we expect it to be. So since we're using this, these are actually fixtures. So you can I've assigned this container fixture to the variable named Postgres. And then we provide as an argument here that actually Pytest will see, okay, you're starting this test with this fixture Postgres, so we'll spin up a Postgres container in the background. And that way you can spin up Postgres Docker containers with whatever external system you have within your test, run some queries or run some operators or whatever you like. And then after the test ends, then your test is finished and the Docker container is killed again. So I see I'm almost out of time, and we're going to the last section, debugging. So let's say you've tested everything, but there's a problem and you don't know what to do. So you have to dive in. There's a couple of tools that we can use for that. One very useful one is Airflow test, the CLI command Airflow test. And you started with Airflow test, DAG ID, task ID, and some execution date. If you're not using the execution date in your DAG code, it doesn't matter what you fill in, but you have to fill in some random date. And basically this runs one single test, and you can put in some debugging statements, print statements, debugging statements, whatever you like, and go from there. And no state about this thing is recorded in your database. With a proper ID, you can set breakpoints and then go into details over here. But sometimes this is not always available, especially in production systems. So if possible, I would try to avoid debugging in production. But if you must, then there's this tool called PDB. It's built into Python. It's short for Python debugger. And this code example actually says IPDB. And that is basically a PDB on steroids with some nice colors and auto-completion and that sort of stuff, which makes your life a lot more easy. So install it with pip install IPDB, and then you can do this thing. Basically you run your task with Airflow test with this IPDB set trace in your code, and then once Airflow hits this line of code, it will stop and you can debug from the command line. If you're looking for all the commands, I would suggest to Google Python or PDB cheat sheet, and you will probably end up on this thing. There's a couple of keys to learn by head, and then you can debug on the command line. And in Airflow 2.0, they refactored the whole CLI to make, to basically be more consistent and make more sense. And as a result, Airflow test became Airflow tasks test in 2.0. There's two more ways to debug. One is the debug executor, added to some recent Airflow version. Basically, you have to say export Airflow core executor equals debug executor, and add this to the end of your DAG script. And then you can run your entire DAG just by saying Python your DAG script. And it will run all the tasks in your DAG, basically in the order that you define them. So you don't have to click on trigger DAG, but just can run it from the command line. And if it then fails, or if it stops on a breakpoint, for example, your terminal is attached to the running process, and you can go debugging from there. I think this is a nice addition to Airflow 2.0. You can actually, you don't have to edit your DAG anymore, like I show here with if name equals main, but you can just run a DAG script just like this for a given DAG ID, given execution date, and then run your DAG from the command line, and you don't have to edit the DAG anymore. Couple of final words. I see we're a tiny bit over the 45 minutes, but basically I hope in the last 45 minutes I was able to show you a couple of examples of how to run unit tests, how to run operators with context or without context, how to run it with a DAG. If you want to avoid making calls to external systems, you can use mocking. Docker is a very useful tool for basically faking real systems. Or I shouldn't say fake, but run real systems but with fake data. And Airflow test can be extremely helpful for debugging. So all talks are recorded. You can watch it back later. I've made the code that I've shown you available over here. So you can check it out, run the code yourself. If you have any questions, you can contact me or one of the channels on Slack. I'm a busy person and might not always respond, but feel free to go to the Airflow Slack and ask questions. And
great, thank you very much. Okay, I think we do have time for one quick question.
Okay.
So, when would you use execute and when would you use run? Is there kind of a rule for one over the other?
Yeah, basically when you implement an operator, your own operator, you're actually implementing the execute. And the execute is basically the very last function that Airflow will call running the logic of an operator. So maybe I can go back. I think it's somewhere here. Yeah. So execute is, this defines the logic that is defined in the operator. So for the bash operator, it just echoes test me. That's all. And the run thing that I show you, A couple of slides down. This thing is kind of a couple of levels of abstraction up, and one of the things that Airflow does within this task.run is it creates the context and feeds this context to your operator, to your task. So if you need to test with the task context, if you're running a task that, for example, uses the execution date, you will need the context. You can run it with this task.run. Or if you know...
I think the other major difference is if you're using templates, if you call execute directly, the templates won't be rendered because they're rendered before execute is called. So if you're using templates, you'll need to call run, not execute.
Yeah, exactly that. So if you have a template string, then that thing is templated just before the execute. So that's why you need a temp.run, task.run.